You all know IEEE, that's for sure. You also know the Geoscience and Remote Sensing Society, GRSS, which works in the realm of well, looking at Earth in general. And the Earth Science Informatics Technical Committee is a group that deals with the IT and computer science aspect of it. Together with two great colleagues, I am working in the TC as one of the co-chairs, and today I have the honor of giving you an overview, a summary of the state of affairs in standardization of Datacubes specifically. So without further ado, let's go forward and start with analysis ready. That has become a very famous term. We don't just want to get data as they are delivered down by satellites. We want to be able to do something with them without having to know so much IT magic. So in order to get them, we need to bring all these various and variety of sensor sources together, also simulated data, and need to unify them. Okay, getting multidimensional spatiotemporal data together naturally leads to the concept of Datacubes, as it's called today. And in standardization, the corresponding concept is coverages, as I will explain in a minute. So the keyword is homogenization, actually. Let's bring all these data together so that we don't see zillions of files, but one Datacube for each satellite instrument. Okay, and then we can look at it, we can mix in other data, we can even have automatic communication from machine to machine, which puts particular requirements on the semantics, on the power of the API, of course. So what is the data model? Well, I mentioned this funny term of coverages. Mathematically, you would say it's a field. Technically speaking, it unites regular and irregular grids, point clouds, and meshes. The point clouds and meshes in the picture are the left side. This is not so interesting today. We focus on the right-hand side, which is the grids. There we had several types, like regular and irregular grids. And the version 1.1 of the CIS standard actually establishes a general concept which also simplifies handling. We have two standards actually in place, two levels, I should say. OGC abstract topic 6, which is identical to ISO 19123, gives an abstract definition. This is not yet down to earth enough that we could have interoperable implementations. It just defines concepts. The interoperability comes in with a concrete coverage implementation schema, CIS, which is identical to 19123-2. So that is the overview. We today focus on those coverages which are gridded. But before getting into that in more detail, let's see the coverage structure in general. Actually, it's quite simple. A coverage is a feature. Okay, so it's a geographic object. It has an identity. In its structure, we find a domain set that tells us where data sit. We find a range set, which is the data payload. And then there's a range type, which defines the semantics of the range set. What do those pixels mean, actually? For this, we use the sensor web enablement data record. Actually, we have shamelessly stolen that in the coverages group from the SWE common people. And that actually means that anything that a sensor observation service delivers, for example, can be carried over into a coverage without any loss of semantics because we duly have exactly the same description with it. So that describes a coverage. Then we typically want to carry along our own metadata. And to this end, the coverage can carry a black bag that can contain literally anything. The coverage doesn't understand it, but it will duly transport such data. And so we maintain connection between data and metadata. Okay, when it comes to an encoding, you like XML? Then maybe this is your kind of thing. You clearly can see the domain set, range set, and range type without going into details now. Maybe it's anyway not your thing. You like curly braces? Okay, here is a coverage encoded in JSON. So that's the CIS JSON encoding, equivalent semantically. Still not your kind of thing? Okay, here we got RDF. Maybe that's what you like to do because you come from a semantic web angle. So you see we have different encodings possible. And those ones which I've shown are indeed informationally complete. As expected, they carry all the information making up a coverage. But that's not what we want typically. We want to be more efficient. We want binary formats. Yes, that's possible too, but they are not necessarily informationally complete. They typically cannot carry all the geodata that we want, for example, in JPEG 2000. Well, sometimes this is perfectly fine, for example, for display on a terminal, but then we sometimes want to have it all. And so the multipart has been set up, which essentially is a container with a header file that is some informationally complete format like GML or JSON or RDF, followed by binary files that make up for the parts of it. That actually can be anything that can hold other data like multipart MIME, zip, and so on, you name it. So we have really different ways to encode such coverages and transport them duly from system to system. And that's it about the data part. Let's now come to the service model. And that means we come to the web coverage service. That actually is not only a single monolithic service, but it's a modular composition. And at the heart of it, we find WCS core, which allows us to access coverages or subsets of it. Well, typically they're big, so we don't want to transport all of them. Therefore, we do subsetting. Subsetting can be a trim operation, like a 2D cutout from a 2D object, or a 3D cutout from a 3D coverage, or it can be slicing, like getting a 2D slice from a 3D time series, or getting a one-dimensional history of one pixel. Trimming and slicing can be mixed freely, and the result you can encode in your favorite format. That's actually WCS core. It's tentatively simple and easy to implement. Extensions add optional functionality facets up to the WCPS, which I want to inspect a little bit in detail. Let me just mention in passing that OGC has compliance tests in place that really test compliance and adherence to the standard of a service implementation down to the level of single pixels. So WCPS, this funny four-letter word, actually stands for Web Coverage Processing Service, and that's a spatial-temporal Datacube analytics language. Works on both regular and irregular grids, and for the sake of time, I just point to the example that gives you a flavor of the syntax without going in details. Just let me mention, like query language, like for example, SQL is very compact, concise. You don't need to have programming skills. You just ship that string to the server and it will evaluate for you what you want to get out. Okay, actually, I shouldn't emphasize so much the API parts. Typically, people just want to get data out, want to visualize them, put them into a GIS. Thanks to the open standards, actually users can stay in the comfort zone and use a lot of tools that can make use of these standards on the level of just visualization, map navigation, up to high-end analysis like coming from Python or R. Okay, so where do we stand? Datacubes, as I said, are normatively modeled as coverages, and they represent that section, that compartment dealing with regular and irregular grids. In OGC, we have both abstract and concrete standards in place. The service model is available, and actually the WCS is not the only one. You can serve coverages through many other service interfaces. There are compliance tests. There is a strong take-up. There are multi-petabytes of data being served with that. So we can consider that standard really mature and stable. ISO works very strongly connected with OGC. ISO 19123 is currently being revised into 19123-1. And once that is ready, we will propagate it back to abstract topic 6 into OGC so that we are in sync. With 19123-2, we have the coverage standard in place, and that is also, so this is ISO standard. The WCS service model is for the future in planning. So this is also mature and stable because it's simply at the same level as OGC. In European Inspire, we find CIS 1.0. It's at that level of the standard, not yet 1.1, and also WCS, WCPS. So actually it's pretty much on the same level with respect to specification. However, it's not yet so fully supported by compliance tests that is under work. And there are just a few demonstration services currently. So that has to be considered work in progress. Another activity on coverages has been done by the World Wide Web Consortium. The spatial data on the web group has established a Datacube model that is based on a statistics Datacube model, not imagery. So it's not exactly fitting. Actually, this work has stopped at some time and I couldn't find a complete specification. There are items left open there. And there's no visible progress since a few years, and I'm not aware of any deployment there. So with OGC, you definitely are on the safe side. So bottom line, coverage implementation schema is the accepted way to do coverages, and in particular Datacubes with a rich ecosystem of services on top of it. But let me also mention that there is always more to do. OGC is working on OAPI coverages as an additional API. We are always thinking about new functionality to add. And of course, harmonization across the different standardization bodies is not coming for free, but means a lot of communication, exchange, and also agreements. With that, I would stop. I would stop with the slides. If we have time, I'm asking Irina here, then I could show you briefly coverages live, some services. But already now, let me thank you for your attention. Apologies again for being so silent in the beginning. And of course, any questions are more than welcome. So Irina,
Yes.
what would you say?
Yeah, thank you very much, Peter. So I would suggest at least to see if there are some questions in the chat. I haven't seen any questions up to now, but we can also allow now if people like to ask some question to raise their hands. Just let us wait for some minutes. If somebody's doing this, then we would first answer the question. And if there's still, if there's less question, then I would suggest you could still take 5 minutes to show the examples if you like.
Okay, sounds good.
I'm just looking if somebody's raising his or her hands to ask a questions. I haven't seen any rising hands here, and I have also not seen. Oh yeah, there's one question in the chat. Okay. If you like, I could just
yes, please go ahead.
Read it loud. Are these services paid services? There is one question.
So first of all, these services would be concrete instantiations, services relying on a particular software and the software based on the standards. The standards of OGC and Inspire are for free. For ISO, you have to pay a nominal fee of 200 Swiss francs for historical reasons, or you get the same thing for free from OGC. So the standards are free and open. The services are different. There are both free and paid services out there. What I wanted to show you is a free service thanks to the kind support of the European Commission. And that would show you, for example, how to map time series data. I tentatively do not show you queries. So we map them on NASA Whirlwind. And gradually we see winter coming on the Northern Hemisphere as we go slice by slice through the Datacube. This is actually demos that we have made to illustrate the use of the standards in action in various situations in life. So if you go to standards.rasterman.com, feel free to explore that yourself. Actually, our Datacube isn't 3D. It is 4-dimensional because it also has a height dimension that you see now. Here we use Microsoft Cesium because it can do better with such things. We can add layers here, we can change the footprint. And so we see that actually we have a 4-dimensional Datacube. I could run the time lapse again, but okay, you have seen that before. Let me rather show you something more advanced. we go into WebGL. And WebGL can do fancy things in the browser if you just feed it properly. And what we have done here is we have a 3-dimensional rendering of a terrain draping with Sentinel-2 data mapped to a digital elevation model. Actually, we can add the band here. And if you don't believe me that this is live, then I show you a sunset scenario where I put the channels to 0. And I like demos. Demo effect. Good. Okay, so let's skip that one and show you another aspect that you actually can link those services based on the OGC coverage standards. And here I'm showing you a query that determines heavy rainfall risk areas. It's formulated in WCPS and it combines precipitation with Landsat 8 data. And we do that by sending it to the German Sentinel Hub code DE. We get a result that we visualize again on NASA Worldwind. But what's more interesting is code DE cannot answer that alone. It had to send a subquery to Cloudflare in Warsaw. They answered their part, send the result back for integration, and we see the result here. That leads us to the idea of federations. And here we have a federation that makes use of that, which is in place and actually has a series of members already. So you find European archives like Mundi Dias and Creo Dias, maritime institutes like Alfred Wegener Institute, over there to Fengchi University in Taiwan, and so on. And we are just about to add several new partners, so this is continuously growing. We have this federation available together with the help of large-scale data centers. And that allows you to get a one-stop shop where the standards are the only interface to get all Datacube analytics and extraction and fusion, etc. You just don't need to know any longer where those data sit. Okay, that was a very brief overview. Of course, I could show you more, but maybe you
Peter,
want to...
there's still one question. Can I just...
I hear there's another question.
Yes. So one question is about if there's a tutorial available, and if yes, where?
Yes, definitely. So the simple thing is Earth server is dealing with Datacubes, so it needs to explain that. So you go to earthserver.xyz/WCS, Web Coverage Service. And then you get a tutorial with lots of links. So not only explanations, but I quickly scroll down a little bit to show you that there are lots of links where you can get tutorials, you can get videos, you can get documents. So I would strongly recommend you to go there. It's easily found, earthserver.xyz/WCS.
There's another question. The question is, can you explain about the CART4L standard by CIOs for analysis-ready data?
Yes. So this analysis-ready term, coined by the USGS Landsat group, has found wide proliferation, although it is not very clearly defined initially. Well, that's not bad, but we need to work on it, and CIOs is working on that. They actually refine that so that we get clear, actionable definitions and rules how to make data analysis ready. This is very much concerning the metadata, and it is to some extent concerning the data part. I am busy in the data part with the Datacubes, and essentially we need both. So this is a very important and relevant step forward, and I hope that can be synchronized in future with OGC, with ISO, so that we have a coherent definition. You know, if you ask me, the differentiation between data and metadata is just artificial. It is historically motivated, but we should go beyond that, and we need to have seamless standards and rules there. So CART4L definitely is an important cornerstone and building block.
Okay, yeah, thank you very much. I think that's all on questions. And yes, I don't know, do you have something to add or to close your session with something that you like to still to tell to the people?
On my side, Actually, I would come back to that one. Please bear in mind, this is where people, like-minded people meet here in the ESI group. So if that is of interest to you, if you have comments, if you disagree, or if you are interested in doing joint research, whatever, please join us there, send us an email. You find us here on that website. I guess the slides will be distributed so that you get the links, or you simply put it into your favorite search engines. And we would be most welcome to have you. We would welcome you very much. Sorry for that. We would welcome you very much with like-minded guys to think about all aspects of earth science informatics. Looking forward to meeting you there.